Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 134 gas station. This is a medium difficulty Leetcode problem, and the problem description tells us that there are n gas stations along a circular route where the amount of gas at the ith station is gas I. And we have a car with an unlimited gas tank, and it cost I of gas to travel from the ith station to its next station. And we begin the journey with an empty tank at one of the gas stations. So given two integer arrays, gas and cost, we need to return the starting gas's station index if we can travel around the circuit once in a clockwise direction. Otherwise, return -1. So if we can't actually, if we can't complete a full circuit before we run out of fuel, then we just end up returning -1. Otherwise, we will return the starting position. In this example, it will be right here. So, that's the problem description. Let's look at an example, because this problem is kind of confusing to get through, but the example really sets us on a good path. So here we have two examples, and actually I'm gonna jot this down over here. So we're going to say the gas is going to be equal to 1, 2, 3, 4, and 5, and then we have the cost. So the cost it takes to go to the next station. So 3, 4, 5, 1, 2. Okay, so we have the gas and we have the cost. Now we want to say, what's the difference? The difference between these, is 1 minus 3, so it's -2, -2, -2, 3, and 3. So these are the differences, right? Well, just by looking at this from a glance, well, we can say, you guys over here, -1, -2, -2, oh, sorry, -2, -2, -2. So basically, all the stations at, index 0, 1, and 2, these stations we can't start at because we'll get the gas, and then by the time we get to the next, before we get to the next station, we will have already run out of fuel. So that's not good. What we want to do instead is say, we can, the answer is that we're told is output 3. So, index 3, so it's 4, and the cost is 4. Sorry, the cost is 1, and the gas is 4. And why does this work? Well, we say we get 3 gas and 3 gas, so we get a total of 6 gas over here, and this over here is -6. So we get -6. We get 6 minus 6, which basically ends up back at 0 over here, but it's 0, but we're already finished. We've already finished the circuit, so we don't need to worry. We are out of fuel, but we've finished the circuit, so that's fine. If it was, if we started at, for example, we started here, well, then we would end up at -2 back at the start, and that's not good because we wouldn't actually get there. So we know this is the answer. So how do we actually solve this problem? Well, we can make a total. We can make a total. Actually, I'll just call this T, and this total is going to be what we have so far, the accumulated total of the difference. It's kind of like a prefix sum almost. So -2. Well, whenever it's a negative number, we'll just set it back to 0. We'll set u to 0. We'll set u to 0. Oh, okay, we've got a 3. So we'll set u to 3. And then we'll set this to 6. But basically, once we get a positive number, a number greater than 0, well then, if our total is greater than 0, then this is a valid starting point. If it goes back to negative, well then we'll reset back to 0 again, and then we'll find the next occurrence is where we'll find our start position. Or if we don't, or we'll have a start position that we've already had before. But basically, we shouldn't end up at negative again. It should be greater than 0, our total. So I hope that kind of makes sense. It's a bit confusing of an example and to describe it, but that's basically the core logic, is finding the difference and then finding the best starting position. So yeah, let's actually get to coding this up. So the first thing we want to do, well, actually I didn't mention this, but we do have an edge case. What if there is, okay, let's go back to the annotation now. So let's say in this example over here, we have this is valid because we have 1, 2, 3, 4, 5, and the cost of this is greater than or equal to this cost. If, for example, there was a higher cost and less gas, there was the sum of gas was not greater than or equal to the sum of cost, well then we would just return -1 because there's not enough gas to actually offset the cost, so there's no point in us doing any computation. So that's going to be the first kind of edge case that we want to, or base condition. So we're going to say sum of gas is less than the sum of cost. Well, then we just return -1, no need for any extra computation. Otherwise, we'll have a total which is equal to 0, and we'll have a start position which is also going to be equal to 0. And we, you might say, why don't we have this as -1? Well, we know for sure that there's going to be an answer. We're guaranteed an answer. If there exists a solution, it's guaranteed to be unique. So if there exists, if we pass this case, we know there is a solution, right? We know that solution will exist. So all we have to say now is for I in range of length of gas, and we're going to increment our total. So total incremented by the difference, right? So gas I minus cost I. So this gives us the difference. So if this ever dips below, 0, well, then we know that we're going to reset our total to 0, and our start point is going to be equal to I plus 1. So we're going to shift it to the next occurrence. So that's going to be our next potential start point, and then we can just return our start point like this. So we return start, and let's check our code actually works. And it does not, because cost is not defined. It's actually cost. So let's submit our code again. It's typo, sorry, my bad, guys. And now it passes all 40 test cases. So in terms of time complexity, we're looking at a big O of n, so linear time complexity. Space complexity, is going to be a big O of 1. We're not using any extra memory. So with that being said, I hope you guys enjoyed this slightly confusing, greedy problem. Easy to code up, hard to come up with, but I hope it did make a bit of sense. And I'll catch you in the next one.